Hello and welcome to the Titus Timeout podcast. I'm Jenny Abney-Civey, and we are often asked how much room you need between the fan box induction inlet and the wall. So I'm going to answer that question today. So just a really quick refresher on fan boxes. A fan box kind of looks like this. It's got a fan, a primary air inlet with a damper. So this is your supply air coming into your fan box. And then over here you have an induced air inlet, which is bringing in the ceiling plenum air into your fan box. The supply air comes in the primary air inlet and into the fan. As you damper the primary air down, you will get more induced air because the fan is set to a specific CFM, and then you'll get a blended temperature air to the space. The induced air inlet acts as your first stage of heating, basically. So this was a series fan box. If you need more information on the series box or the difference between a series and a parallel box, I'll put a link down to the podcast about fan boxes in the notes below. So let's move this out of the way. So I've drawn the induction port. It's on the same side as the inlet, so you wouldn't really have a wall right next to it, blocking it. But different models can have their induction ports in different places, so it could be on the side like this one, where you have your primary air coming in here and your induced air coming in here. Make a little room. Or it could even be on top like this. So again, your primary here and your induced air on top here. So how do you know how close you can put it to a wall or the ceiling? Well, you know you can't put it directly against the wall because then no air can get in, but what if you only leave a couple inches like this? Will you have enough opening for the air to come into the box? Okay, move this out of the way again. So we recommend that it should not be any closer than half the equivalent duct diameter of the induction inlet. So let's say we have a fan box and it has an induction inlet that is 18 1/4 by 12 inches. What's the duct diameter for this 18 1/4 by 12 inch inlet? Luckily, ASHRAE has an equation for that. The ASHRAE equation for circular equivalents of rectangular ducts for equal friction and capacity is 1.3 times the duct height times the duct width to the 0.625 power, divided by the duct height plus the duct width to the 0.25. So for our box here, you have 1.3 times 18.25 times 12 raised to the 0.625 divided by 18.25 plus 12 raised to the 0.25, and that comes out to 1.3 times 219 to the 0.625 divided by 30.25 to the 0.25. And then that, when you work that all out, is 16.1 inches. So for our 18 1/4 by 12 inch induction port, you would need to be at least 8 inches from the wall or any other obstruction for proper performance of the fan box. This could be especially important if you look at a fan box with a top induced air inlet, because you usually want to hang the box as close to the top of the ceiling plenum as possible. So with a top inlet, you'd actually need to be, in this case, 8 inches below the ceiling. So that's how to calculate the equivalent duct diameter and how to use it to determine the proper installation location of your fan box. Don't forget to subscribe to our YouTube channel, and thanks for taking a time out with us.